Okay, so how do we solve these guys? It's actually pretty simple. The only kind of trick is that you have to realize that what we're looking for is just x equal to something, okay? The simpler we can get something to be, the more useful the answer, but you can't make, sometimes you just don't have enough information to do any better than something that looks ugly. So in the first example, we want to have, if we want to solve for x, we've got this x minus 29 times the square root of the natural log of z divided by y. And what we can do is, if we want to get x by itself, we can add 29 square root of natural log of z over y to both sides, because, hey, that's allowed. These cancel at that point, and we end up with x is equal to 29 times the square root of the natural log of z over y. And in this case, that's good enough. Because we don't have any information about y or z, there's no way we can simplify this, but we solved for x and we did as best as we could. Now for the next one, we're going to also start with the same approach, and we end up with these. We're going to add y to both sides. Those y's cancel out. We get x squared is equal to y. But now we can go a little bit further. We want x equal to something, not x squared equal to something. So what we're going to do is we're going to use our exponent rule, try to get rid of this by multiplying it by something that, like by its reciprocal, because we want to have an exponent equal to 1 so that we can just drop it. This thing has an exponent of equal to 1. So we're going to raise both sides to the power of 1/2. And we're going to end up with x is equal to y to the 1/2. And again, we don't have an exact number here, but that's the best we can do, and we've answered the problem. We've given the problem what it's looking for. We've solved it as best we could.